because that goal will serve to organize and measure the best of our energies and skills, because that challenge is one that we're willing to accept.
Hello, my name is Teeter, and what you've been watching is my 3D GameMaker Studios 2 demo running real time at 45 frames per second and under a gigabyte of memory. If you have been following the demo thus far, you'd know getting it under a gigabyte of RAM was one of the main goals I had sought out to complete. And now I'm there, but I'm afraid, for I cannot stay. A game is more than just a renderer and must have content too.
Protocol Layer 09.
So when you last heard from me, everything was still a struct, every block, every entity, but now we're down to an integer. And although that gave me a huge boost in performance, it did come with its downsides. Now, every single block type has to be loaded in at the beginning of a game, because I am merely referencing the structure and data that is set out and no longer holding it within the chunk. This is a very convenient system if you plan on only having blocks in your game, but I don't. So how do I do it? I know how last video I said I was trying to stay away from built-in DS data structures, but I did have to go ahead and use a map this time so I can more efficiently store world objects that don't count as blocks. And yet, I am still using only one integer to reference them in the world. I do this by data packing. By data packing, I mean the process of storing several numbers inside of one 32 or 64-bit integer. For my case, I'll be working with 32-bit integers because on some exports of GameMaker, with bitwise operations, it will restrict you to 32 bits. So let's take our 32-bit integer. It itself can store 4 bytes. Inside of those bytes, those can represent up to 255. Now, combine 2 of those bytes together, only using half of the 32-bit integer, and we can represent a number up to 65,535. And you can go lower than 1 byte. I myself am using 1 control bit and then 2 bits for rotation on my packed data. I'll go ahead and show you my data structure from this current project. The first 10 bits are allocated to item ID. I don't think this number will ever go over 1023, so I do feel 10 bits is appropriate. The next few flags are for world objects. These are non-block objects that are represented in the world and stored in data too. First, you have your host, aka origin. If this bit is flipped, this is the cell that is holding the representation for this object. Everything else is merely going to reference it. The second one is rotation, a 2-bit number representing up to 4 rotations. Next, we have the last 19 bits. Currently, I'm using these for object instance IDs. This is one of the harder problems I did have to solve for when doing the non-block based objects. What I have set up is a global map that stores all active world objects that are loaded in on a chunk and its host chunk if that host chunk is in fact loaded in. And as you can see, those are represented as unique IDs up to, in the current project, number 524,287. I did the math to see if this would be an appropriate amount for the world size, and I came to the conclusion of, if we load this many on screen to begin with, it is not going to run. So there is no reason to worry about this, and just keep it at a number which you think it will never exceed. Some might think that I'm going a little bit overboard with a few of these mechanics, like data packing, 2D culling, and saying that I am using more efficient but more restrictive algorithms. And to them I say, wait a few more weeks for the next demo. For now, I'll show you a few more things that I put in. First, we have my favorite, Crazy Mode. This is a shader that can be amplified, turned on and off, and will be used for horror elements inside of the game. I've also added in a start screen so I don't have to recompile every single time. This will be useful whenever I do finally release my demo. Other than that, it's been mostly doing the groundwork for optimizations that are later going to be needed, and getting objects larger than 1 block being able to be represented inside of the engine. So that's about all I can show you right now, other than optimizations to the code, but those aren't that fun to see. Next week I'm going to be tackling AI issues, having fluid dynamics and pathfinding without bringing down the FPS of my engine.